Hello again. Right. So now we're on to the next session, which is we're going to hear from some practitioners who are actually using 3D printing for at their company. We're going to hear about the company that's supporting them doing that as well. So and also some of the novel designs of applications that are enabled through the use of additive in the drone world. So I'd like to welcome Gino and Robert to the stage. Here we go. So I'm going to sort of leave you to get on with it. I'll be back a bit later to sort of field any questions from the audience as well. So Gino, over to you.
Perfect. Thank you very much, Michael. And good morning, good afternoon, everybody. My name is Gino Baristreri, and I'm leading the efforts into the unmanned systems industry globally for HP Additive Manufacturing Solutions. So HP provides an industrial part of that technology for production applications called multi-jet fusion. And today we'll talk about how this technology is changing the industry of drones. So around 2 to 3 years ago, we actually started to seeing a lot of parts being printed at our contract manufacturers, and we actually tried to understand why that was the case, and that effort basically grew out through tremendous growth to become the trusted solution for end-use components on a very wide range of drones. And we even set up a core team that is just focused on this industry. So from established companies to the most promising startups, we're helping them getting the most out of their unmanned systems. There's 3 takeaways I want you to take from this. Is 1, additive provides tremendous value to the aerial vehicle space that we talk about today. MGF is the go-to solution for drone components and up to entire airframes. And the first fully 3D printed aircraft, both for defense and for commercial applications with up to 2-meter wingspans, are additively manufactured, both of them with multi-jet fusion. Now, rather than go in detail into our value proposition, rather show you our use cases from like compact FPV drones up to those airframes with 2-meter wingspan. And this is where Robert Miller will come into as well, as he will deep dive on his recently launched drone for a genuinely inspiring use case related to anti-poaching. All right, let's go straight into it. All right, so first, which industries do we actually see a lot of growth? And there's a very wide range of industries where we see growth happening. First one is actually agriculture, in order to monitor the crops that you need to that you have across a wide range of land. And so really good use case for drones, unmanned systems to do that. Up to healthcare, bringing medical supplies to people, for example, across countries like Africa, but also already in across hospitals and medical centers in Western countries. Up to security and surveillance, right? Think about big ports, for example, where drones are a very good use case to cover. But a completely other side is entertainment. We'll show and see an FPV example, but also actually the largest light show providers are using MGF as well for those light shows that are basically replacing to a certain extent fireworks shows. And then last mile delivery. I mean, you're not getting your Uber Eats order yet by drone, but this is a market actually growing very fast, and we'll see a cool example on that one as well. And then there is the defense space. Given the geopolitical situation, and there's several NATO countries building out their defense industries, and this includes drones as well. Now, why is it the case that they use MGF? It's because MGF enables them to print highly complex, very lightweight, and functionally integrated drone parts that optimize aerodynamics and flight performance. And kind of this design freedom and the fact that the speed of design in in the drone space is so fast, it's really hard to keep up with conventional manufacturing solutions. And so having a production solution for that, that you can actually prototype with and then go to production with as the designs are changing, that's been one major factor. And we can actually create the lightest and the thinnest UAV components compared to any other AM technology. And you see a really good use case at the end there. Now, in terms of printed parts, there's a very wide range. Think about airframes, combustion systems, electronic housing, propeller holders, battery covers, and components of wings, up to even landing gear. So a very wide range of parts being printed already. Just waiting to switch to the next one. There we go. So first use case. So we're starting with FPV drones. Unusual Machines is a company that manufactures and sells drone components and drones across several brands, actually, Pet Shark, and they use their Rotorite e-commerce store, very famous brand in the FPV side. And they actually have a commercial product uses MGF that's being produced by Forecast 3D in San Diego. And it's called the Skylight, one of the top-selling platforms that they have, and really being used to the, let's say, the extremes of sports and things like this, like you see here. Very cool application. And several reasons why they went for it. One thing is clearly the strength and durability that they get with the TPU parts, and it's kind of ideal for the high requirements that they need into FPV drone operations. There's actually numerous parts on this drone printed with MGF and TPU, and the fact that we can print them all in one shot obviously helps them a lot as well from an assembly standpoint and an efficiency standpoint, and the resilience of the material. Even when it crashes, it remains virtually indestructible and protecting the drone. That's been a big reason for them. So for those that are not following yet, they're a very popular YouTube channel. I definitely recommend you to do so. Now, going to slightly smaller drones, when we look at like portable designs, there's several really cool cases, one from Spain here and one from the United States. So UAV Works actually is the company behind the first one. Is actually a highly transportable but also collapsible multi-copter. So they have several features. For example, the folding mechanisms that you see here are all directly 3D printed with MGF. And you can actually, so 96% of the drone is 3D printed, and you can simply like fold the drone together and then put it in your backpack, for example, and carry it with you. It's completely optimized from a weight standpoint, and we consolidate as many parts we could together. And it actually has the thinnest possible walls that you could print in additive already on it. So lightweight is super important in the drone space. Every gram gives you more flight time. So that's one thing that we work together with them on. And on the other hand, we're looking at how can we actually optimize the structural integrity. And this is where Nico partnered with Autodesk in order to make portable drones for rapid deployment and reconnaissance. How can I bring a complex geometry that can only be done in additive for a scalable solution and only in one piece? And that's what they did here with the drone that you see here. Another very good fit. They tested a wide range of technologies, and they came up with MGF for the right large technology to go, given the scalability and how light the drone ended up to be. Now, going one step bigger, so quadcopters, a very famous use case of drones as well, or type of drones as well. So here's the Athera from a company in India called Vecros, very fast-growing company. Very interesting drone that they have here. It's kind of an AI-powered quadcopter that can autonomously navigate the world around it, detect and avoid obstacles, and do several tasks, mainly inspections, 2D to 3D mapping, data collection, analysis. So there's a lot of things that the drone can provide here. Several reasons why they switched to MGF. One part is on the structural side and the aerodynamic side, so they were able to make like a very robust chassis. That's of course important for quadcopters, but also kind of streamlining the aerodynamics, while still from an aesthetic standpoint making it like kind of futuristically looking. Then there's the functional integration, so they could bring several parts together. Think about like semi-closed vents that they put into the design in order to have an effective air transfer, but also protect internal components. So they really thought through how they can use MGF to the maximum, making it very efficient to assemble, and also having a modular design in the sense that they could basically like change out components for different applications with the quadcopter. And given that they don't need support structures with powder bed technology, they also really use this design freedom to make the drone look super cool. Okay, then there we have 3 more drones left. So one is the Blue Flight drone. So Blue Flight, a company based in Michigan, a very innovative company. They actually focus on producing a last mile delivery platform. Here you see their cargo system. It has like an enclosed payload area on the top, and it has 4 tilting motor arms, so to eliminate the need to pitch the fuselage during the flight. So quite an innovative way of flying their system. They basically focus on delivering like consumer goods, but also medical products, industrial supplies, and I know that they've been actually extending that quite a lot. So very interesting use cases that they cover with the drone, and where traditional methods actually that they've been using initially came with limitations in strength, in geometry, or in weight, they actually were a little bit restricted, and with MJF, they were able to address those constraints and actually reduce the weight with 25% on a final platform. In drone terms, that is a massive amount of range that you're adding. Now, this is because of the, let's say, the weight, I mentioned that, but also the repeatability when scaling up as they get more demand. And they have already like 48 parts on their aircraft, actually already more, that they are doing, from body panels to battery covers and landing gear. So a very wide range of applications being covered. Really cool use case. And now going to the 2 largest drones that I can share today. One is from Firestorm. Firestorm is a company based in the US, disrupting the mobile manufacturing space. Their flagship product, you can see it here, is the XL. It's basically a mobile manufacturing unit capable of directly producing drone components, spare parts into the field. So it's housed in 2 20-foot containers, and it integrates multi-jet fusion, automation, and assembly for rapid production in the field. So a very interesting case that they built out. The drone that they have that they offer, one of the drones they offer is a Tempest. It's a modular multi-mission class 2 UAV. So you see here, and it has like modular payloads, changeable engines, and a very wide range. Very interesting how it's not only extremely lightweight, it costs a fraction of the production value, and it's also much faster to produce. So a very, very impressive case that they have made. And just to show you, when it moves to the next slide, there we go. It's not just the concept that you saw here, the drone in the field is actually already has proven to be able to fly, and it's a very interesting drone case that they built. So with that, I'm going to introduce Robert Miller from the Eye Above. Very inspiring use case that he's been working on. I'll play a video just to show you what use case that is, and then I'll pass it to Robert to present.
Okay, Gino, it looks like we don't have audio. Well, Hi everyone, I'm Robert Miller from the AMAA. Sorry we didn't have audio on that video, but it's a great pleasure to be here talking to everyone today about a project that's actually got a lot of people excited and is getting a lot of attention around the world. So maybe, Gino, if you can drop to the first slide, if you don't mind. So let me give you a little bit of background maybe about how the AMAA came to be and what the project's all about. Essentially, it started with a late friend of mine who had an interest in a share block in a nature reserve with a big poaching problem. And I was fortunate enough to actually spend some time up there and get to see firsthand what the rangers deal with on a daily basis. And you realize very quickly that they're at war with poachers, and they're actually fighting a losing battle in many cases. South African bushveld is some of the most hostile environment in the world. If you're walking through the bush, maybe you can see 3 to 4 meters around you. And unless you can get a bird's eye view of what's going on, you stand almost no chance of tracking the poachers. They can go to ground, they can hide under a tree. And I realized we had to do something. So I decided, let's get a drone. I mean, obviously, this is the obvious solution. Let's get the rangers a drone. Let's get them an eye in the sky. But I realized very, very quickly that this wasn't going to work. And having done a little bit more research, the general consensus was that drones do not work in anti-poaching, which didn't make sense. If you've seen what's happened in Ukraine, drones should be able to work everywhere. So, Gina, if we can move to the next slide. So we took a step back and said, okay, what does a drone need to be able to do to succeed in the South African bushveld environment? We conducted a study speaking to various experts, rangers, people in anti-poaching, and the requirements were it needed long flight duration, it needed to be extremely durable, withstand high winds, rain, and pervasive dusts. And we're talking winds in excess of 60 kilometers an hour. It had to be repairable in the field. It had to have minimal moving parts. You're often dealing with people who are not used to high technology in the bushveld. If you have moving parts, if you've got control surfaces, someone's going to pick up the drone and you're going to break a control surface. It had to be easily transportable, and it had to be adaptable with a variety of payloads, because there are more and more sensors and more cameras and more technology coming out on a daily basis. And we didn't want to build a platform that was going to become obsolete very quickly. Do you know if we can move to the next slide? Oh, by the way, in that last slide, there was a rhino hiding there. They're not always easy to see. So very, very early on, we took the decision we wanted to actually use additive manufacturing for this drone. The decision was based on the fact that composite materials, while lightweight, are very, very difficult to repair, especially in the field. And to manufacture them, there's quite a barrier to entry. You have molds, you require autoclaves. And when we were going to build an aircraft that was radically different, we didn't want to have to retool and remold every single time we made a change, or every time we decided to try something new. Foam had insufficient strength and durability. A number of foam aircraft have tried to get into the anti-poaching arena, and the environment just destroys them. We've also discovered that ants love foam for building nests. We needed advanced structures that we couldn't use subtractive manufacturing for. The only way we could actually build them to get the lightweights and strength we needed was additive manufacturing. So what we decided to do was to take traditional materials like carbon fiber, put them on the inside, and to put other materials on the outside. Started off, ironically, evaluating SLS and MJF right from day one. Neither was successful. In those days, it was the HP MJF 4200. We weren't getting the thicknesses we need. We weren't getting the tolerance. We were getting warping. The SLS with the kind of wall thickness, and I know someone in the chat asked, we are looking at wall thickness across the skin of the aircraft of 0.8 millimeters, consistent. And we just weren't able to achieve that, a uniform smooth surface on SLF or the early MJF units. We then moved to SLA. We didn't have, they were too brittle on an aircraft like this, the SLA parts. In fact, all of the SLA fuselages we received were broken in transit. We didn't even get to assemble one of them. Then we looked at FDM. We had moderate success with FDM, but the early prototypes of the airframe would creak and crack every time you picked it up. I mean, FDM can work at thicker wall thicknesses. We've set it around 1.2 millimeters. You have something that is usable. We've seen lots of hobby drones and small drones, but we needed something that was commercially viable. And then actually someone from HP that we spoke to previously reached out to me and said, well, he's got a new 5600 series. Do I want to try it? And to be honest, my hopes weren't high, given what we had experienced, but started talking to the team in Barcelona. And the first airframe that Barcelona printed had none of the problems we saw with any of the other airframes in the past. It was rock solid. Every single part pretty much fitted together. In fact, maybe we had too much tolerance on parts based on what we were using. And bar a few changes, that airframe could have actually been flown. PA-12 is extremely durable. With a modular airframe like this, which you can take apart, put together, and really abuse, we found if a part gets damaged, we can often repair it with just super glue. And if we can't repair it with super glue, you just remove the part and replace it. Whereas with a composite airframe, generally you're looking at a replacement of the entire airframe section or the entire fuselage. Do you know if you could move to the next slide, please?
Yep.
Yeah, let's just see. So we approached this slightly differently. We didn't try take a conventional airframe and move it to AM or MJF. We redesigned the entire airframe for MJF from the start. You'll see a very unusual pattern on that picture there. We actually have a cell structure that lets us consistently have 0.8 millimeter walls that are actually really, really hard to break. You can put your finger through them, but they've been designed to take the kind of stresses that this airframe is going to experience in the field. Also, by moving to a structure like this, we overcame some of the big problems, and we are improving continuum about how to get the powder out. So for those of you who've never used a powder-based system, you don't need support material because the powder that actually creates the part is the support material. The problem comes in that once you have the part, now it's full of powder, and you need to understand how to get the powder out afterwards. If we can move to the next one, Gino. So what we ended up with is the Bush Ranger. It's one of the first rear transition VTOLs around. It has a radically different design to most VTOL aircraft. It's 90% 3D printed. It's mostly field serviceable in that all the components can be taken apart and put together in the field. It's completely modular. So if you, for example, break a tail, you remove the whole tail assembly, put on a new tail assembly, and send the other one back for refurbishment. It has advanced sensors. It's got a thermal and optical payload. It carries a high-resolution Sony camera, and currently we're working on a synthetic aperture radar for snare detection from the air. We can move to the next one, Gino.
Mm-hmm.
But this is just where our journey begins. The project isn't just about saving a species or an ecosystem. It's about upliftment of people as well. So our first deployment is in Kafue in Zambia in conjunction with Endangered Wildlife Trust and International Crane Foundation. That is a proving ground for the Bush Ranger, where it will be monitoring crane populations, critical habitats, and hovering and photographing nests. That's where we start to look at the onboard systems, where we need to start making changes and how we can improve it. Post Kafue, we move into the greater Kruger landscape, where we again are partnering with Endangered Wildlife Trust and various conservation authorities. Here, we are going to be looking at putting the radar in, and we're going to be looking at trying to identify the majority of snares from the air. So the rangers, instead of spending their day hunting for snares, can rather go out in the morning and just remove snares. But if we don't bring the local communities in, okay, we are going to continue to have a poaching problem, because a lot of these communities have nothing. They've got no money, they've got no food, they've been forgotten in a lot of cases. So part of the plan is to actually initiate a drone pilot and maintenance crew training program where we will identify candidates from the communities and we will make them part of the solution. Do you know if we can move to the next slide? We're almost out of time. Well, that was perfectly timed. So if you want to know more about the project, please scan the QR code. If you want to get involved, please reach out to us. It's only going to succeed with interest from the public and the corporates like HP who've come on board and helped drive this forward.
Fantastic. Thank you so much, Robert, for presenting that. And the same on our side. So feel free to reach out to us as well. Michael.
Thank you. Yeah, I was really just engrossed in that, and I saw a lot of questions coming up from the audience as well. So we'll leave the QR codes up for a bit longer. Where do you see this going next, Robert? What's your you've given a bit of the shorter term sort of roadmap with the 2-stage projects. Where are we going to be in a couple of years?
So the anti-poaching project has actually given rise to commercial projects. When we set out, we were building a conservation aircraft. We very, very quickly realized there were big applications for this kind of aircraft in search and rescue surveillance. What we didn't expect is the interest from the military. Every time we've been to a show with HP, we've actually had the military come to us and say, we want that now. This is the kind of aircraft we're looking for. It meets all of our requirements. So we do have a commercial arm that is looking at going into the commercial space and the military space, and we're busy engaging with potential partners right now in that space. But we've also had conservation organizations around the world reach out to us and say, we want this drone. So we're already talking to organizations in Middle East, in Africa, in America, and hopefully this project is actually going to expand all over the world.
I love the involvement of the local community there as well that you mentioned. We'll be returning to this topic of UAVs with a couple of the companies you mentioned, Gino. We're going to have Firestorm on. We're going to have Blue Flight, and we're going to be getting into a panel discussion as well. So if this is a topic that's interesting for you, please do stay around. We're going to be changing gears slightly for the next session. We're going to be talking to the Performance Review Institute and some of the practicalities of actually getting parts onto aircraft. But Robert and Gino, thank you so much for your time today. I hope you can stay around for the rest of the day and join us back, at least participating on the panel later on.
Thank you, Michael, and thanks for the opportunity.
Thank you, everyone. And stick around. We'll be back with the next session ASAP.